Hello, welcome again. Geometry section 8.6 today. Law of sines and law of cosines. Law of sines. If triangle ABC has lengths A, B, and C representing the lengths of the sides of the opposite angles with measures capital A, capital B, and capital C, then the following proportion setup holds true, that the sine of A over side A is equal to the sine of B over side B, which is equal to the sine of C over side C. There is a proof that goes through and clarifies this and justifies it. We're going to take it as true and apply it in different situations. First question says find P and round to the nearest tenth. So we have a triangle, obviously, PQR, and we have two side lengths, 8 and 1 as a variable, and two angles. From that, we also know what angle Q is if we wanted to solve for it. We'll apply the law of sines to solve for P, probably using the sine of P over P and the sine of R over R to put it together. Statement says we are given measures of two angles and a non-included side, so the law of sines, so we'll use the law of sines to write the proportion. Okay, and we'll do that. Sine of P over P is equal to the sine of R over R. Applying the information from the previous picture, we know that the sine of 17 over P is equal to the sine of 29 over 8. Now, this goes back to our proportion solving from chapter 7, and we will cross multiply and solve. We will end up with 8 sine of 17 is equal to P sine of 29, and just like when we had variables next to each other, we want to get one to the other side, we will divide. So we'll divide both sides by the sine of 29, and we'll end up with P is equal to 8 sine of 17 over the sine of 29. Solving for side P, then we'll plug this in our calculator and we'll end up with approximately 4.8. Now, typing this into our calculator may be tricky at first. Here's the parentheses sequence that we'll need. Parentheses 8 sine, kicks out your own parentheses, 17, close the parentheses for the sine, close the parentheses for the numerator, division, parentheses, sine, kicks out its own, 29, close, close. If you type that in your calculator, you will not have any errors, and you'll end up with the 4.8 for P. Again, repeating the answer, 4.8. So that is using and applying the law of sines. Let's do another. This one says find C to the nearest tenth. So I'm trying to find C. I do have the angle across from C, angle A and angle A and sides A are also there as well. So we'll use the sine of A over little a is equal to the sine of C over little c. Applying, we'll have the sine of 47 over 16 is equal to the sine of 23 over c. Cross multiply, and we will have 16 sine of 23 is equal to c times the sine of 47. Divide both sides by the sine of 47. We're left with c is equal to 16 sine of 23 over sine of 47. C then will approximately be, after we solve, 8.5, which is D. So again, applying the law of sines to a triangle and solving. Alright, law of sines. Here we're going to solve for an angle. Given some pieces of information, it says find x round to the nearest degree. So we have the law of sines. Sine of A over A is equal to sine of B over B, and we'll apply what we know from there. We do know that the variable A will go as x, so sine of x over 11 is equal to the sine of 50 over 10. Same rules apply. We'll cross multiply. We'll be left with 10 sine of x is equal to 11 sine of 50. To get x by itself, we need to divide by 10 first. So we'll have sine of x is equal to 11 sine of 50 over 10. And just like we had to do before with the inverse trig functions to get rid of a sign, we're going to have to do the same thing here. So on both left and right side of the equation, we're going to have to take sine inverse. So we will have x is equal to the sine inverse of 11 sine 50 over 10. Now again, the key sequence for your calculator here will be the sine inverse, kicks out parentheses, and then we will have parentheses 11 sine, kicks out its own parentheses, 50, close for the sine parentheses, close for the numerator, division 10, and close for the sine inverse. If you type that sequence in your calculator, then you should end up with the approximate value, which is 57.4. So this is using law of sines to solve for the angle of a triangle. And again, repeating the answer, 57.4. So now we can apply for the sides and also solving for the angles. And let's do another example here. Find x, round to the nearest degree. So sines, we have sine of x over 10 is equal to the sine of 55 over 12. Cross multiply. 12 sine of x is equal to 10 sine of 55 divided by 12. Sine of x is equal to 10 sine of 55 over 12. Do the sine inverse. You have x is equal to sine inverse of 10 sine, I'll have to erase that there, sine 55 over 12. Plug that in your calculator. Okay, x is approximately then 43. And if you did not get the correct answer and you need the sequence for the parentheses, remember it would be sine inverse parentheses 10 sine, kicks out its own 55, close, close, division 12, close. There is the law of sines. Countering the law of sines, we have the law of cosines. The law of cosines can be applied with different pieces of information, and the three sides, A, B, and C, can be solved for with the following equations. The first one is a squared is equal to b squared plus c squared minus 2bc cosine A. And if you look, the pattern is pretty much the same, and then you can see it color coordinated throughout. Whatever side you're trying to solve for, A, B, or C, the other two sides are squared. So in the very first one, the sides that not are A, B, and C are squared. And then those two sides are multiplied together but with 2 and the cosine of the angle I'm trying to solve for. So when you're trying to solve for B, A replaces all of the B's from the previous example. Okay, so those just flip-flop. And that happens for all three. So really, you don't have to memorize or know three different equations, just one equation manipulated in three different areas. Alright, let's apply the law of cosines in a situation. Here it says find x round to the nearest tenth. So I have one side, an angle, and two other sides, and I cannot use the law of sines because I don't have a second angle to solve. So I'll use the law of cosines instead. It says use the law of cosines since the measure of two sides and the included angle are shown. So law of cosines in this situation, I call them A, B, and C. They're going to call them x on the other side. So x squared equals y squared plus z squared minus 2yz cosine x. Let's fill it in with information we know. From the picture, we had y is 11, z is 25, and then the angle was 45 degrees. Once we have that situation set up, then it's just a matter of simplifying in our calculators. 11 squared plus 25 is going to be 746, minus 2 times 11 times 25 is 550, and the cosine of 45. Then we can just type that in right exactly as is in our calculator, and then we just need to square root it as well at the end. So we'll square root the whole thing, and we'll simplify and get our answer, which is approximately 18.9. Now typing that in your calculator may be another trick, so we'll show you the keystrokes here. Square root button kicks out its own parentheses, 746 minus sign, 550 cosine, kicks out its own, 45 close for the cosine, and close for the square root. So that would be the key sequence for the calculator solution. And again, repeating the answer, final answer was x is approximately 18.9, and that is one version of the law of cosines.